All right, number 12 here, the length of pregnancies of humans, normally distributed, mean 268, standard deviation of 15. Find the probability of a pregnancy lasting more than 300 days. Okay, so this is really just find the probability. So let's find an area of it lasting more than 300. So we want the probability that X is greater than 300, which we're going to convert to a probability that Z is greater than something. To do that, we find what Z is. So 300 minus 268 over 15. That'll come out to be about 2.13. So really we're asking what is the probability that Z is greater than 2.13. Looking at a normal, so 2.13, and we're looking at this area here. Of course, to get this area here, we're going to have to get the area to the left here, and so take 1 minus that. So if I bring up Excel here, we're going to do norm is dist 2.13, comma, true. All right, and then do 1 minus that. Whoops, I forgot the equals 1 minus that, and we get 0.0166. Okay, right there. All right, an airline knows from experience the distribution of numbers of suitcases that get lost in a certain week. So it has a mu of 15.5, sigma 3.6, probability will lose between 10 and 20. Okay, so again, we're just going to do this as the area between the 10 and 20 points, but we're going to need the z-scores for each of these. So the z for 10 would be 10 minus 15.5 over 3.6. And that's approximately negative 1.53. And the z for 20 is 20 minus 15.5 over 3.6. It's approximately, or is actually 1.25. And then, so we're going to do the area. So let's call that negative 1.53. Let's call that 1.25. We want this area in here. So we would just have to do a couple of z-scores here and subtract. So we'll do norm dot s, s dist. What was the bigger one? 1.25. Okay, and then do negative 1.53. And then I'm just going to subtract this one minus this one and get 0.8313-ish. And a little rounding difference, so we'll take that one. All right, distribution of cholesterol levels, teenage boys, mu 170, sigma of 30. All right, levels above 200 warrant attention. All right, so if you have 95 teenage boys examined, how many would you expect to have cholesterol levels greater than 225? So we really want to find the probability first. So let's convert to the z-score. So we're doing 225 minus 170 over 30, which is about 1.83. Okay, and then so I'm going to find out 1.83, the probability of being bigger. Okay. Alright, so I'm going to go 1.83 in there, but I want 1 minus that. So 0.0336. All right, so that's the probability. So then I'm going to do 0.0336 times 95, which is going to give me about 3.2, and so I'll just approximate that to be 3. The z-score that corresponds to the given area. Okay, so this is just going backwards here. Again, I'm given this area to the left. If I want to look up, I should probably do the area. I'm given the area to the right, and I want the area to the left. So I'm going to do 1 minus that 0.9564, which is 0.0436. And then this is the value that I'm going to look up in my inverse. So equals norm S inverse this time, and we're going to look up the 0.0436, giving us negative 1.71. Okay, find the z-scores for which 90% of the distribution's area lies between negative z and z. All right, so we're being asked to find 90% between. So this 90% is inside there. Okay, that means that 10% is going to be left for the tails, or in other words, 5% in each of these. Okay, so 5%, 0.05. Okay, so I really have an area of 0.05 that I'm going to look up. So we'll use what we had here with the inverse. 0.05. Negative 1.6, and we'll give it the 3 decimal places, negative 1.645. So this one is negative 1.645, and this is positive 1.645. So there it is. So now let's compare two scores, 75 on a test with mean 65 and deviation 8. All right, so the first one, the first score of 75 is going to be 75 minus 65 over 8. The other one is going to be 75 minus 70 over 4. All right, but both of these, this would be 10 over 8. So this is 1.25, and this is also 1. Whoops. 1.25. So these are the same. They are statistically the same.